Alright, so we've worked with graphing with a few labs now, and I'm hoping that maybe you're picking up on some of these trends, but if not, this should point them out very clearly for you. But a graph is so much more than numbers in a line, and you should be able to look at graphs based on what's on their axes and be able to make a judgment as far as what's happening. Alright, so we're going to start by discussing some distance time graph, or another way of referring to those are ST graphs, because S is distance and T is time. Alright, so way to think about this is really, all of the graphs we're going to talk about, time is on the x-axis. But we want to kind of pay attention to what you're actually looking at on y. Alright, so distance. If, say for example, this first picture down here, as time increases and your distance doesn't change, are you moving? Hopefully you're saying no. Okay, so on a distance time graph, when it makes a horizontal line, we say that the object is at rest. Alright? Let's look at some more things that could happen on a distance time graph. Alright, so you can also have, and we've seen this before in a lab, a straight line that's at an angle. Alright, so if you notice, if your position, as time increases, your distance increases. Okay, so that should imply that you're moving, but more importantly, it implies that you are moving at a constant speed. Alright, so your speed is not changing, and what that means is that, every second you move the same amount of distance. Alright, and if you think about it, your slope is the rise, the distance, per time. Okay, so your slope actually ends up giving you your speed. So the slope on this graph is your speed. Alright, and we kind of discussed this when we did the dune buggy lab. Another comparison that you can have is the greater the slope, alright, so the steeper the line, the higher the speed. Alright, so like this line would be much slower compared to the other two, and then the red line would be super fast, faster than everything. Okay? So these are some ways, just by looking at a graph or looking at two graphs, you can make some comparisons without even knowing any of the numbers on the lines. Alright? Then the last thing that you will see sometimes with distance or ST graphs is this curve. Alright? When we did the acceleration lab, you should have noted there was kind of a curve to how your distance was changing over time. So what this means is that your speed isn't constant, it's actually changing, which means there's some sort of acceleration going on. In this case, if the distance that you're traveling gets higher, right, like you're traveling more distance per time, like in the picture right here, then that means you are accelerating. Okay? So, a couple of things just to kind of sum up from this. So for an ST graph, if you have a horizontal line, it means you're at rest. If you have an angled line with a slope, you're moving at a constant speed. And then if you have a curved line, you are accelerating. So those are ST graphs. Okay? So that's kind of the summary that we were talking about here. Alright. One thing that we didn't quite talk about yet is you can also show when you move backwards on this type of graph. Alright. So if you look here, you can see our constant speed. Constant speed. Here you can see at rest. Here is accelerating. Alright, and then this is something we haven't seen yet, but if you think about this being where you started, if you come back to 0 on your like a y equals 0, you've gone back to start. Okay? So let's practice with this a little bit. All right. And let's look at, and this time you do actually have some numbers on here, and they do come in handy, but which of the graph shows that one of the runners started 10 yards further ahead of the other? All right, so which axis should you look at? I hope you are saying that since it's talking about 10 yards, that means you're talking about your distance or your position, so you need to be looking at the y-axis. All right. And then now you want to sit there and find out where they are. One of them starts out 10 yards ahead. All right. So if you notice these two, you're starting at the same point, so it can't be those. So then if you look at the other two, here you're starting at 0 and you go to 20. That's 20 yards ahead, so that's not it. But this one, 0 and 10 yards, so your answer is A. So another set of practice. In which of the following graphs below are both runners moving at the same speed? So how on a distance time graph or an ST graph can you see speed? I hope you are saying slope. All right, so you want to look for the graphs that have the same slope. Here we have one that's steeper than another, so this can't be it. Again, the top one is steeper than the other, so this can't be it. And here we have, especially if they're crisscrossing, they can't be it. All right, now here we have two lines that don't intersect, that aren't getting further apart from each other or closer to each other. They are parallel, and that means same slope. Okay? So last set of practice related to distance time graphs. All right, so distance time graphs below represent the motion of a car. Match the descriptions with the graphs and explain your answers. So these questions, granted, I won't have you do the explanation part, but these questions will be showing up on your online assignment. Okay? So reference this when it starts asking for them. And then I will also be checking to see that this is completed when you get to class. This is essentially your notes. Okay? So that's the end of this one. Now there is another type of graph that we're going to observe, and you want to watch that video as well.